Now let us understand force polygon method with one example. So in this example, the question is that find the resultant of following coplanar concurrent forces. So these are the number of forces that is acting at point O. So this is the point where all the forces are acting, and by using force polygon method we have to find out the resultant of this given forces. So for the solution of this example, if we start with first applying Bow's notation in clockwise direction to the space between the two consecutive forces. So these are our number of forces. So between that we have to write down a small letter that is generally known as the Bow's notation. So between these two forces, A is there, then 60 Newton and 50 Newton. Between that, small b notation is there, then C notation is there, then between 40 Newton and 30 Newton, D notation, then 30 and 20 we have to provide notation E, and between 20 and 10 Newton we have to provide notation F. So this is called a Bow's notation. Now for the solution of this we have to first take a appropriate scale. So let us say the scale we require to select, that is 1 centimeter is equal to 10 Newton. So with this scale we have to draw a polygon, and we take a starting point, that is considering the A point, and in our force polygon we have to use a small letter. So first of all, draw a parallel line in the direction of this 60 Newton force. So before that we have to mark one horizontal line, so it will provide a baseline for the all the forces. So first of all we have to draw a small horizontal line, and on that line we are providing point A somewhere here. So let us say this is our point A. Now between A to B, if we go, there is a 60 Newton force with this direction. So considering appropriate angle, so to consider that we also required some uh, vertical line here. Now for the taking a exact 60° on that particular point, so considering this as a horizontal, this is our 60°. So we have to first of all plot 60 Newton force considering this given scale. So we have to take a 6 centimeter, that is equal to a 60 Newton with the given scale. So this is our point B here, and this force is 60 Newton force. So we just write down this is 6 centimeter with the given length, and here the point is point B. So joining the A to B, that is a 60 Newton, converting with the scale, that is a 6 centimeter. Now again we plot a small horizontal line here to take a appropriate angle. Now we start with the B here, so it is B to C. Now that is a 50 Newton force. So again we put a angle of appropriate scale. So with this vertical, if we draw vertical here, so we require to take 45 degree as angle. So again we take a 45 degree as an angle here, and considering the actual length of 50 Newton force, that is nothing but a 5 centimeter. So again we draw a second line, that is of a 5 centimeter line, and that is our second force. So that is stop at point C. Now third force, that is from C to D, so that is of 40 Newton, and that it is exactly a horizontal line. So we draw a 4 centimeter horizontal line here. So that is our third force, that is completed at point D. After that we have another force, that is 30 Newton force, and that is starting from D to E, and with some angle, and that angle we take with the horizontal, that is about 60 degree. So again we put this here, and that 60 degree somewhere here, and taking the scale, the appropriate length of that force, that is 3 centimeters. So we start with 6, 5, 4 and 3. So that is exactly a 3 centimeter length force. And this, if we write down the dimension of all the lines, so this is 5 centimeter, this is 4 centimeter, and this one is a 3 centimeter. Now again last force, that is E to F, and this point, that is point E, and E to F we have a 20 Newton force. So considering that 20 Newton force, that is exactly a 2 centimeter vertical downward line. So we draw that line here to here, that is exactly a 2 centimeter line, and that point is a F point. So this is a force 20 Newton. After that F to A, that is again a 10 Newton force with some 5 degree. Okay, so little bit taking a 5 degree as angle, and 10 Newton, that means a 1 centimeter line. So this is a F to finally a point. So here we have to take a dash point, that is our last point. Now again we have to join that A and A dash point here. So now A dash and A, that we connect with this, so that is exactly 2.1, the length of A to A dash, that equals to 2.1 centimeter, right? We can also measure the angle. You can measure angle with this particular horizontal, so that we take a theta. So theta is equal to, here if we measure it exactly, so the appropriate angle is exactly 18 degree. So theta is equal to 18 degree. So here we can say that the A dash, and that exactly equal to our resultant of this given forces. So after this completion of graphical representation of a force polygon method, resultant of the given force, that is with some value, and that value is corresponding to the selected scale, so that is 21 Newton, and that is acting 18 degree angle with the horizontal like this. So this is all about solution of a resultant of a given problem.